The radio died at the worst possible moment. December 19th, 1944. Ardennes Forest, Belgium. Tank Commander James Patterson was leading a column of 12 M4 Sherman tanks through the snow when the static in his headset went silent. Not gradual degradation, just silence. One moment, he could hear Lieutenant Morrison's voice from the tank 200 yards ahead. The next moment, nothing. He tried transmitting. Baker 3 to Baker 1, radio check. No response. He switched frequencies. Tried the battalion net. Tried the company net. Tried the emergency frequency. All dead. The SCR 508 radio set mounted in his turret had simply stopped working. This wasn't unusual. The SCR 508 was temperamental. Tubes failed. Connections corroded. The generator that powered it was driven by the tank's engine, and rough terrain caused vibrations that shook components loose. Radio failures happened to every tank crew eventually. What made this failure critical was timing. The column was moving to intercept a German armored assault. Intelligence said approximately 40 Panzer IVs and Panthers were pushing through the American lines 15 miles northeast. Patterson's company, Baker Company, 7th Armored Division, was supposed to coordinate with Able Company to catch the Germans in a pincer movement. That required communication. That required working radios. Patterson pulled his tank to the side of the road, signaled the tanks behind him to halt, got out, and walked forward to Morrison's tank. The cold hit immediately. -8 degrees Celsius. Wind cutting through gaps in his jacket. Snow crunching under boots that weren't designed for winter warfare. Morrison saw him coming. Climbed out of his turret. Radio problem. Complete failure. Can't hear anything. Morrison nodded toward the forest ahead. German assault is 12 miles out. Moving fast. If we don't coordinate with Able Company, they'll hit us piecemeal. We need working comms. I know. Can you fix it? Not here. Not in 20 minutes. The tubes are probably blown. Need replacement parts. We don't have 20 minutes. That was the problem. Tank radios failed frequently. But usually you had time to troubleshoot. Time to replace components. Time to work through the technical manual's fault-finding procedures. In combat, time didn't exist. You either had working communications, or you didn't. And if you didn't, tanks operated independently. Each commander making decisions based on what he could see from his limited perspective inside 30 tons of steel moving at 25 miles per hour. The American doctrine for armored warfare assumed radio communication. Tank platoons coordinating movement. Companies executing flanking maneuvers. Battalions maintaining formation. All of it required commanders talking to each other. Without radios, doctrine collapsed. Tactics collapsed. Coordination collapsed. 40 tanks became 40 individual vehicles hoping they were doing the right thing. Patterson looked at the antenna on Morrison's tank. Standard issue. 4 feet tall. Whip antenna. Flexible steel with a copper core. Mounted on the turret rear. It worked fine under ideal conditions. But ideal conditions meant flat terrain within 3 miles. In forests, the effective range dropped to maybe 1 mile. In snow and cold, range decreased further. 1 mile. That meant the lead tank could talk to maybe 3 tanks behind it. Everyone else was guessing. The German panzers didn't have that problem. Their FUG radios had better range, better reliability, better antennas. That gave them coordination American tanks couldn't match. Patterson stared at that antenna and thought, this is the problem. This 4-foot piece of steel. This is why we can't coordinate. This is why German armor keeps breaking through our lines. And he wondered if there was a way to fix it. Chapter 1. The Communication Problem. Radio communication in armored warfare was supposed to solve the coordination problem that had plagued tanks since World War I. Early tanks operated blind. No way to talk to other tanks. No way to coordinate. Each tank was an independent unit. If 5 tanks attacked together, they weren't really attacking together. They were 5 separate attacks happening simultaneously. By 1944, every American tank had radios. The SCR 508 in the M4 Sherman was considered adequate by Army standards. It transmitted voice on frequency modulation between 20 and 27.9 MHz. Power output, 25 watts. Theoretical range, 10 miles under ideal conditions. But ideal conditions didn't exist in combat. The Ardennes forest was dense. Trees absorbed radio waves. Hills blocked line-of-sight transmission. Weather affected propagation. The actual working range was closer to 1 mile, sometimes less. German tanks had superior radio equipment. The Fug-5 radio set used in Panzer IVs had 10-watt output, but better frequency stability and clear modulation. More importantly, German doctrine emphasized radio discipline and coordination. Tank platoons maintained constant communication. Company commanders controlled multiple platoons simultaneously. German armor moved as coordinated units instead of collections of individual tanks. Patterson had seen this firsthand 3 weeks earlier during a skirmish near Bastogne. His platoon of 4 Shermans encountered 6 Panzer IVs. The American tanks spread out, each commander making independent decisions. The German tanks moved in coordination. 2 Panzers maneuvered while 4 provided covering fire. When the American tanks tried to flank, the German formation adjusted instantly. All 6 tanks responding to commands from their platoon leader. The result: 3 American tanks destroyed, 6 crewmen dead, 4 wounded. The Germans withdrew with no losses. Not because their tanks were better. The Sherman and Panzer IV were roughly comparable. Because their coordination was better. They fought as a unit. The Americans fought as individuals. After that engagement, Patterson requested a briefing with the battalion communications officer. Captain Frank Holloway had been responsible for radio maintenance for 2 years. He knew the SCR 508 inside out. Patterson asked the obvious question: can we increase transmission range? Holloway's answer was direct: not with current equipment. The 508's power output is fixed at 25 watts. You can't change that without redesigning the transmitter. And the antenna is already optimized for the frequency range. What about a longer antenna? Longer isn't better. Antenna length needs to match the wavelength you're transmitting. The 508 operates around 27 megahertz. That's an 11-meter wavelength. The 4-foot antenna is already a compromise. Make it longer, and you introduce impedance mismatches. Signal efficiency drops. So we're stuck with 1-mile range. In forests, yes. In open terrain, you might get 3 miles. That's the limitation of the equipment. Patterson left that conversation frustrated. The radios were inadequate. Everyone knew it. But fixing it required equipment redesign. That meant factories, engineering teams, months of development and testing. Meanwhile, tank crews died because they couldn't coordinate. That night, Patterson sat in his tank reading the technical manual for the SCR 508. Page 47 covered antenna specifications. Whip antenna, 4 feet tall. Impedance, 50 ohms. Standard military specification. Used across all armored vehicles. But the manual included a footnote. A small note at the bottom of the page. Antenna performance may be improved with proper impedance matching and ground plane configuration. See Appendix C for technical details. Patterson turned to Appendix C. The technical details were dense. Electrical engineering terminology he barely understood. But the core concept was clear. Antenna efficiency depended on more than just length. It depended on impedance matching, ground plane, and radiation pattern. Change those variables, and you could improve performance without changing the transmitter. The manual didn't say you should change them. It just said you could. And that was enough to start him thinking. Chapter 2. Improvising a solution. The supplies arrived on December 16th. Not official radio equipment. Just general maintenance supplies. Patterson requisitioned 6 spools of copper wire, 4 coils of steel cable, various connectors, insulation tape, and wire cutters. The supply sergeant asked why he needed them. Patterson said antenna maintenance. That was technically true. He started experimenting on December 17th. His tank was down for track maintenance anyway. While the crew worked on the suspension, Patterson worked on the radio antenna. The standard antenna was 4 feet of flexible steel with a copper core. It screwed into a mount on the turret rear. Simple, functional, inadequate. Patterson's idea was to extend it, not just make it longer. That would cause the impedance mismatch Holloway had warned about, but add additional radiating elements that wouldn't interfere with the primary antenna's function. He started with the simplest design, a vertical extension. Unscrewed the standard antenna. Attached a 6-foot length of copper wire to the top using a brass connector heat machine from a shell casing. Wrapped the connection in insulation tape. Secured the extended antenna to the turret with steel cable. The result was ugly. a 10-foot antenna wobbling above the tank like a fishing rod. It looked absurd, but appearance didn't matter. Function mattered. He tested it at 1,800 hours. Called Morrison's tank, which was parked 400 yards away, well within the standard antenna's range. The transmission was clear, normal strength. Then he tried raising Sergeant Collins' Enable Company, who was positioned 2 miles north. With the standard antenna, Collins was out of range. Patterson had tried contacting him yesterday. No response. With the extended antenna, Able 4, this is Baker 3, radio check. Static. Then, Baker 3, Able 4, I read you strength 3. Strength 3 meant weak, but readable. Not perfect. But the standard antenna would have gotten nothing at 2 miles in forest terrain. The extension was working. Patterson tried different configurations over the next 24 hours. Extended the antenna to 12 feet. Signal strength improved slightly, but the antenna became difficult to secure. Too much wind resistance. Tried 8 feet. Better compromise. Tried adding horizontal elements to create a ground plane. That improved the radiation pattern. Signal strength at 2 miles increased to strength 4. But each modification introduced problems. The extended antennas were visible. Very visible. A 10-foot antenna was a target marker. Snipers could spot it from a mile away. German tank commanders would know exactly where to aim. The risk was significant, and the antennas kept breaking. The connections were fragile. Rough terrain shook them loose. Branches in the forest caught on them and bent them. After 3 days of testing, Patterson had gone through 4 different antenna configurations. None lasted more than 6 hours of actual movement. On December 19th, he tried a different approach. Instead of one long vertical antenna, he built a dipole configuration. 2 6-foot wires extending horizontally from the standard antenna mount. Secured both to the turret with insulated standoffs made from rubber gaskets. The result looked like a capital T above the turret. Tested it at 2,000 hours. Called Collins again at 2 miles. Able 4, Baker 3, radio check. Baker 3, Able 4, reading you strength 5. Clear transmission. What did you change? Strength 5. That was excellent signal quality. Better than the standard antenna achieved, even at close range. The dipole configuration was working. The horizontal elements created a better radiation pattern. The signal propagated further with the same 25 watts of transmitter power. But it looked ridiculous. 2 6-foot wires sticking out sideways from the turret. The tank looked like it had grown metal insect antennae, and it was even more visible than the vertical extensions. Lieutenant Morrison saw it the next morning. His response was immediate. That's the stupidest thing I've ever seen on a tank. Chapter 3. Resistance from Command. The order came down on December 20th. Battalion Commander, Lieutenant Colonel Edward Briggs, wanted to see Patterson immediately. Patterson reported to the command post at 0900 hours. Briggs was direct. Tank Commander, I understand you've been modifying radio equipment without authorization. Yes, sir. Extended the antenna to improve transmission range. You're aware that unauthorized modifications to military equipment are prohibited? Yes, sir. You're aware this could result in disciplinary action? Yes, sir. Briggs pulled out a photograph. Aerial reconnaissance shot. Patterson's tank with its horizontal antenna wires clearly visible. This was taken yesterday by one of our observation planes. Your tank looks like it's trying to grow wings. Do you understand what you've done? Extended radio range from 1 mile to approximately 3 miles, sir. You've made your tank a target. Those antenna wires are visible from any German position within 2 miles. You might as well paint a bullseye on your turret. The improved communication is worth the visibility risk, sir. That's not your decision to make. Combat doctrine specifies standard equipment configurations. You don't get to improvise because you think you have a better idea. Patterson stayed silent. Arguing with a lieutenant colonel was career suicide. But the logic was wrong. The doctrine assumed working communications. When communications failed, doctrine failed. Improvisation wasn't optional. It was necessary. Briggs continued. I'm ordering you to remove those modifications immediately. Return your antenna to standard configuration. Is that understood? Yes, sir. Good. Dismissed. Patterson returned to his tank. His crew was waiting. Corporal David Martinez, the gunner, asked the obvious question. We taking off? Patterson looked at the antenna. at the horizontal wires that had tripled their radio range, at the modification that let them coordinate with tanks 3 miles away instead of just the tanks directly visible. The choice was clear: follow orders and accept limited communications, or disobey orders and maintain the tactical advantage. He thought about the engagement near Bastogne. 3 tanks destroyed because they couldn't coordinate. 6 men dead because each tank operated independently. The German panzers coordinating as a unit, while American tanks fought alone. "No," Patterson said. "We're keeping it." Martinez raised an eyebrow. "Sir, that was a direct order." "I know, but in 6 hours, we're engaging German armor. I'm not going into combat with a 1-mile radio range when I can have 3 miles. Court-martial me after we survive." The crew didn't argue. They'd been in enough engagements to understand what poor communication meant. They'd watched friendly tanks get destroyed because commanders couldn't coordinate. They'd seen what German armor could do when it operated as a coordinated unit. At 1,400 hours, Morrison approached Patterson's tank. Saw the antennas still configured with horizontal wires. "Briggs told you to remove those." "He did." "You're ignoring the order?" "I'm postponing compliance until after combat operations." Morrison was quiet for a moment. Then, "Show me how to build one." Patterson spent the next 2 hours teaching Morrison the antenna configuration, how to attach the horizontal elements, how to secure them with insulated standoffs, how to test signal strength. Morrison's crew built their own extended antenna by 1,600 hours. By 1,800 hours, 4 tanks in Baker Company had the modified antennas. By 2,000 hours, 6 tanks. Lieutenant Morrison was telling other commanders about the improved range. Word was spreading despite Briggs's order to remove the modifications. The rebellion was quiet. No one announced they were disobeying orders. They just built the antennas and kept them. Briggs would notice eventually, but by then, maybe the combat results would speak for themselves. Chapter 4. First Coordinated Engagement. The German assault hit at 0600 hours on December 21st. 40 Panzer IVs and Panthers pushing through the forest road northwest of Bastogne. American intelligence had predicted the attack. Baker Company and Able Company were positioned to intercept. Standard tactics would have each company engaging independently. Baker Company attacking from the south, Able Company from the north. No overall coordination. Just 2 separate engagements happening simultaneously. But Patterson had working communication with both companies. His modified antenna reached Morrison's tanks in Baker Company and Collins's tanks in Able Company. 3-mile range meant he could coordinate both forces. Not officially, he was just a tank commander, not a company commander. But radio communication didn't respect rank structure. If you could transmit, you could coordinate. The German column appeared at 0615 hours. 40 tanks moving in formation. 2 columns of 20 tanks each. Panthers in front. Panzer IVs following. Standard German assault doctrine. Heavy armor leading. Medium armor supporting. Patterson transmitted. All Baker units, all Able units, this is Baker 3. Targets approaching from northeast. Count 40 enemy tanks. Recommend we let them enter the kill zone before engaging. Morrison's voice. Baker 1 confirms. Hold fire until they're centered. Collins from Able Company. Able 4 confirms. We have visual on the lead elements. The German column moved into the valley between the 2 American positions. The Panthers were magnificent machines. 45 tons. 75 millimeters KWK, 42 gun. Frontal armor, 80 millimeters thick. Nearly invulnerable from the front. But they were focused forward, looking for threats ahead, not watching their flanks. Patterson waited until 30 German tanks were in the kill zone, then transmitted. All units, commence firing. Baker units target the Panzer IVs in the rear column. Able units target the Panthers in the lead column. Coordinate fire on my mark. 3, 2, 1. Mark. 12 Sherman tanks, fired simultaneously from the south. 8 tanks from the north. 20 guns firing at once at targets 800 yards away. The coordination was precise. Baker Company hitting the rear German tanks. Able Company hitting the lead tanks. The German column trapped in between. The result was devastating. In the first salvo, 9 German tanks were hit. 6 Panzer IVs destroyed outright. 3 Panthers damaged. The German formation fragmented. Tanks trying to turn to face threats from two directions simultaneously. Patterson transmitted. Baker units, advance 200 yards and fire again. Able units, hold position and continue targeting Panthers. The maneuver worked. Baker Company moved forward while maintaining fire. The German Panzer IVs tried to engage, but couldn't coordinate a response. Half were turning south to face Baker Company. Half were turning north to face Able Company. Their formation collapsed into individual tanks fighting independently. Over the next 40 minutes, the coordinated attack destroyed 23 German tanks, 9 Panthers, 14 Panzer IVs. The remaining German armor withdrew in disorder. American losses: 2 Shermans damaged, 1 destroyed, 3 crew casualties. The tactical difference was communication. Patterson's modified antenna let him coordinate 20 tanks across 3 miles. That coordination created a crossfire that prevented the German tanks from forming a coherent defense. They couldn't respond to threats from 2 directions simultaneously. Their superior armor and firepower became irrelevant when they were caught between coordinated American forces. After the engagement, Morrison pulled his tank alongside Patterson's. That antenna of yours just saved about 30 American tankers. Briggs is going to be furious. But if he tries to court-martial you, every tank commander in the battalion will testify that your modification won the engagement. Patterson nodded. But he wasn't thinking about court-martial. He was thinking about the 17 German tanks that escaped. If more American tanks had the extended antennas, they could have coordinated a pursuit. Could have destroyed the entire German formation instead of just half of it. 20 coordinated tanks had defeated 40 German tanks. Imagine what 40 coordinated American tanks could do. Stories like this deserve to reach those who value them. If this account held meaning for you, consider helping others discover it. A like tells the algorithm to share this with similar audiences. Subscribing to the channel and enabling notifications ensures these stories reach you when new accounts are published. Your engagement becomes a form of historical preservation, connecting those who seek this knowledge with those who've taken time to document it properly. Chapter 5. Word Spreads. The after-action report reached division headquarters by December 22nd. 20 American tanks engaging 40 German tanks with minimal losses. The numbers were remarkable. Unusual. They triggered questions. Colonel Thomas Gardner, the division operations officer, reviewed the engagement details. Noticed the coordination between Baker and Able companies. Noticed the precise timing of the crossfire. Noticed that tank commanders from 2 different companies were communicating effectively across 3 miles of forest terrain. That shouldn't have been possible with standard radio equipment. Gardner drove to the battalion command post on December 23rd. Asked to see the tanks that had participated in the engagement. Patterson's tank was first. Gardner walked around it twice. Stared at the horizontal antenna wires extending from the turret. "What are those?" he asked Patterson. "Extended antenna configuration, sir. Improves transmission range." "Improves by how much?" "Approximately 3 times standard range. 1 mile becomes 3 miles. And you built this yourself?" "Yes, sir. Using spare parts and wire from supply." Gardner was quiet for a long moment. Then, "Show me how it works." Patterson demonstrated. Called Morrison's tank 2 miles away. Called Collins's tank 3 miles away. Both responses were clear. Strength 4 or better. Gardner tested the standard antenna on an unmodified tank. Could barely reach Morrison at 2 miles. Couldn't reach Collins at all. The comparison was obvious. The extended antenna worked significantly better than standard equipment. Gardner asked the question that mattered. Can this be replicated? Can other tank crews build the same modification? Yes, sir. Takes about 3 hours with basic tools and materials. I've trained 6 crews so far, all operating with extended antennas now. And the visibility issue? The extended wires make tanks more visible to enemy observation. Yes, sir. But improved coordination more than compensates for increased visibility. We can position tanks more effectively when we can communicate across 3 miles instead of 1 mile. Gardner made notes. Then asked to see Lieutenant Morrison's tank. Same horizontal antenna configuration. Then Collins's tank. Same design. All 3 were identical. The modification was standardized. Reproducible. Not just one tank commander's improvisation, but a repeatable procedure any crew could implement. That afternoon, Gardner convened a meeting with the battalion's tank commanders. 32 commanders attended. Gardner explained the antenna modification, explained the improved range, explained the December 21st engagement, where 20 coordinated tanks defeated 40 German tanks. The reaction was mixed. Some commanders immediately wanted the modification, understood what improved communication meant for tactics. Some were skeptical, worried about visibility, worried about violating regulations. Some were dismissive, thought better radios should come from official channels, not field improvisation. Lieutenant Morrison spoke up. I was skeptical too. Thought the extended antennas looked ridiculous. But after the engagement on the 21st, I'm convinced. Coordination wins tank battles. This modification gives us coordination that matches or exceeds German radio capabilities. That's worth the visibility risk. Sergeant Collins agreed. Able Company lost 3 tanks last week because we couldn't coordinate with Baker Company. The standard radios don't have a range. This modification gives us the range we need. I'm installing it on every tank in my platoon. The debate continued for an hour. Eventually, 28 of the 32 commanders decided to install the modification. The other 4 remained skeptical, but agreed to wait and see results. Over the next 3 days, Patterson and his crew trained other tank commanders, showed them the antenna configuration, provided wire and materials, helped them build and test the modifications. By December 26th, 40 tanks in the 7th Armored Division had extended antennas. By December 28th, 60 tanks. The modification spread beyond official channels. Tank commanders talked to each other, shared information. The crews with extended antennas reported better coordination, better tactical outcomes, fewer losses. The crews without extended antennas noticed the difference and requested the modification. It was becoming standard equipment, not through official procurement or engineering approval, through field adoption, crews building what worked instead of waiting for what was authorized. Chapter 6. Battle of the Bulge. The German offensive in the Ardennes began on December 16, 1944. 3 German armies attacking through the weakest point in the American lines. The goal was to split Allied forces and recapture the port of Antwerp. It was Germany's last major offensive of the war. By December 28th, the offensive had stalled. American forces had held key positions at Bastogne and elsewhere. German supply lines were overextended. The weather was clearing, allowing Allied air support. The situation was stabilizing, but not resolved. On December 29th, German armor made one final push. Approximately 60 tanks, Panthers and Tiger IIs, attempting to break through American lines northeast of Bastogne. If successful, they'd cut off the American forces in the city. If they failed, the German offensive would collapse entirely. The 7th Armored Division was positioned to intercept. They had 52 tanks available. Normally, 52 tanks against 60 would be a disadvantage. The German tanks were heavier, better armored, more powerful guns. But 43 of the American tanks had Patterson's modified antennas. That meant 43 tanks that could coordinate across the entire battlefield. The engagement began at 1,400 hours. German tanks advancing in 3 columns. American forces spread across 5 miles of front. With standard radios, coordinating across 5 miles would be impossible. Each American unit would fight independently. The Germans would have numerical and technological advantage in each local engagement. But with extended antennas, the American tanks could coordinate as a single force. Patterson wasn't commanding. That was Captain Harold Jensen's job. But Patterson was on the radio network, listening, contributing, helping maintain coordination across the entire formation. Jensen's orders were clear. All units maintain positions. Let German columns approach to 1,000 yards. We'll engage from hull-down positions. Concentrate fire on lead tanks. When lead tanks are destroyed, German columns will stop. We'll have better firing positions than they do. The tactic worked. German columns approached. American tanks waited in prepared positions behind terrain that protected their hulls. Only turrets visible. When the range closed to 1,000 yards, 43 American tanks opened fire simultaneously. The coordination was devastating. Each German column faced fire from multiple directions. The lead Panthers took concentrated fire. 7 tanks destroyed in the first 90 seconds. The German columns stopped. Tanks spreading out, trying to find the American positions. But the Americans were hull down. Harder to see. Harder to hit. Jensen coordinated the next phase. Baker Company, flank left. Charlie Company, flank right. Able Company, maintain direct fire. We're surrounding them. Standard radio equipment couldn't coordinate that maneuver. The companies were spread across 3 miles. Standard radios had 1-mile range. But with extended antennas, all 3 companies heard Jensen's orders clearly. They executed simultaneously. Baker Company moving left. Charlie Company moving right. Able Company maintaining fire from the center. The German formation was trapped. American tanks attacking from 3 sides. The Germans tried to withdraw, but the flanking companies cut off their retreat. Over the next 2 hours, the coordinated American attack destroyed 37 German tanks, 12 Panthers, 9 Tiger IIs, 16 Panzer IVs. The remaining German tanks retreated in disorder. American losses: 5 tanks destroyed, 11 damaged, 7 crewmen killed, 23 wounded. But the German offensive was broken. They'd committed their last strategic armor reserve, lost 2/3 of it. The Battle of the Bulge was effectively over. The battle report noted, unprecedented coordination between American armored units resulted in decisive tactical victory. Multiple companies maintained communication and executed coordinated maneuvers across extended battlefield. Enemy forces unable to respond effectively to simultaneous attacks from multiple directions. What the report didn't mention was the extended antennas, the field modification that made that coordination possible. The stupid antenna trick that let 43 tanks coordinate like a single machine. But the tank commanders knew. Every one of them understood what had made the difference. Not superior equipment, not better training. Coordination, communication, the ability to fight as a unit instead of as individuals. Chapter 7. Official Recognition. General George Patton visited the 7th Armored Division on January 3, 1945. He'd heard about the December 29th engagement. 60 German tanks defeated by 52 American tanks with minimal losses. He wanted to understand how. Patterson was among the tank commanders summoned to brief Patton. 15 commanders standing in a field next to their tanks. Patton walked down the line, inspecting each tank. He stopped at Patterson's tank, stared at the horizontal antenna wires. What the hell is that? Extended radio antenna, sir. Improves transmission range approximately 3 times over standard equipment. Did you design it? Yes, sir. Built it for spare parts. Other crews have replicated the design. Patton walked to the next tank. Same antenna configuration. Then the next. Same design. 11 of the 15 tanks had the extended antennas. How many tanks in the division have this modification? Approximately 70, sir. Across 3 battalions. Patton turned to Colonel Gardner. Why wasn't I informed about this? The modification began as unauthorized field improvisation, sir. Tank Commander Patterson violated regulations by modifying radio equipment without approval. It only became widespread after the December 21st engagement demonstrated its tactical value. Unauthorized. Patton repeated the word flatly, then turned back to Patterson. You violated regulations? Yes, sir. Risked court-martial? Yes, sir. What? Standard radio equipment was inadequate, sir. 1-mile range in forest terrain meant tanks couldn't coordinate. German armor was defeating us because they had better coordination. The extended antenna gave us equivalent capability. Patton was silent for a long moment. Then, Colonel Gardner, I want every tank in 3rd Army equipped with this antenna modification within 2 weeks. I want standardized construction procedures. I want training for all tank crews. I want this implemented across the entire Army group. Sir, the modification hasn't been officially approved by Ordnance Department. It hasn't undergone. I don't care about Ordnance Department approval. It's been tested in combat. 70 tanks. Multiple engagements. Demonstrated results. That's better testing than anything Ordnance Department does in peacetime. If this works, we're using it. Official approval can catch up later. Gardner nodded. Yes, sir. I'll coordinate implementation. Patton turned back to Patterson. Tank Commander, you're promoted to 1st Lieutenant effective immediately. You're also being reassigned to division headquarters as communications officer. Your new job is training tank crews to build and install this antenna modification. Questions? No, sir. Good. Patton looked at the horizontal antenna wires again. It looks ridiculous. Like your tank grew whiskers. But if it works, I don't care what it looks like. Wars are won by people who solve problems, instead of waiting for permission to solve them. That afternoon, Patterson began training crews. The division established a standardized procedure. Antenna construction took 2 hours. Materials required: 12 feet of copper wire for insulated standoffs, connectors, mounting hardware. Total cost per installation, approximately $8. The procedure was documented in a field manual supplement distributed to all units. Within 2 weeks, 320 tanks in 3rd Army had extended antennas. Within 4 weeks, 600 tanks. The modification spread to other Army groups. British armored units in Northern Europe began testing similar designs. Canadian tank units adopted it. By February 1945, extended antenna configurations were standard across Allied armored forces in Europe. The U.S. Army Ordnance Department officially approved the modification on February 18, 1945, 3 months after Patterson built the first prototype. 2 months after had become standard practice in 3rd Army. Official approval lagging behind field adoption. Engineering validation following combat results instead of preceding them. The official designation was Antenna, Extended Range, Field Modification M1. But tank crews called it the Patterson antenna. The name stuck despite Patterson's objections that dozens of other crews had contributed to its development and standardization. Chapter 8. Engineering Analysis. The Signal Corps Research and Development Laboratory at Fort Monmouth, New Jersey, received a Patterson antenna for analysis in March 1945. They wanted to understand why the field modification worked better than the standard antenna their engineers had designed. The analysis took 3 weeks. The results were published in a classified technical report on March 28, 1945. The key finding: Patterson's modification created an accidentally optimized radiation pattern. The standard SCR 508 WIP antenna was a vertical monopole. It radiated energy in an omnidirectional pattern around the tank. Most of that energy went upward into the sky. Only a small fraction propagated horizontally toward other tanks. This was inefficient but adequate for short-range communication. Patterson's horizontal wires created a dipole configuration. The radiation pattern was no longer omnidirectional. Instead, energy concentrated horizontally, exactly the direction needed for tank-to-tank communication. Less energy wasted into the sky. More energy propagating toward other tanks at ground level. The horizontal orientation also provided a secondary benefit: better ground wave propagation. Radio waves at 27 MHz could travel along the Earth's surface, following terrain contours, penetrating obstacles. The dipole configuration enhanced this ground wave propagation. Signal could reach through forest vegetation and around hills that would block line-of-sight transmission. The engineering analysis concluded that Patterson's modification improved effective radiated power by a factor of 4.8 at ground level. The transmitter still output 25 watts, but the antenna directed that power more efficiently toward horizontal targets. The practical result: range increased from 1 mile to approximately 3 miles in forest terrain. For miles in open terrain. What impressed the Signal Corps engineers most was that Patterson had achieved this without formal antenna training. He'd understood the problem intuitively, recognized that vertical antennas were wrong for horizontal communication, experimented with configurations, found something that worked, then standardized it for other crews. The report included a recommendation: the extended dipole configuration should become standard equipment for all armored fighting vehicles, not as a field modification, but as factory-installed equipment. Future tank designs should incorporate horizontal antenna elements as primary radiating systems. That recommendation was implemented in post-war tank development. The M26 Pershing tank, entering service in late 1945, included horizontal antenna elements as standard equipment. The M46 Patton tank in 1948 had an improved dipole configuration based on Patterson's design. Modern armored vehicles still use variations of the horizontal dipole concept. But the larger lesson was about innovation under constraints. The Signal Corps had designed the SCR 508 radio system in peacetime. Lab testing, controlled conditions, theoretical optimization. They concluded a 4-foot vertical antenna was optimal. Patterson had tested in combat. Real terrain, real interference, real-world constraints. He'd concluded a horizontal dipole was better. Field testing proved him right. The difference was environment. What worked in laboratory conditions didn't necessarily work in forests with terrain interference and limited line of sight. This gap between laboratory design and field performance became a case study at military engineering schools. The lesson: field testing under actual operational conditions matters more than laboratory optimization. Engineers should design for the environment where equipment will actually be used, not the control conditions where it's tested. The Army revised its equipment development procedures in 1946. New regulation required field trials before equipment approval. Representative environments. Real operational conditions. Feedback from actual users. The Patterson antenna incident demonstrated that frontline soldiers often understood equipment limitations better than engineers who'd never used the equipment in combat. Patterson's contribution wasn't just the antenna design. It was proving that field innovation could exceed laboratory engineering. That practical testing under combat conditions revealed problems and solutions that controlled testing missed. That sometimes the best improvements came from users, not designers. Stories like this deserve to reach those who value them. If this account held meaning for you, consider helping others discover it. A like tells the algorithm to share this with similar audiences. Subscribing to the channel and enabling notifications ensures these stories reach you when new accounts are published. Your engagement becomes a form of historical preservation, connecting those who seek this knowledge with those who've taken time to document it properly. Chapter 9. Post-War Career. Patterson remained in the Army after the war ended. The transition from combat officer to peacetime officer was difficult for many veterans. Combat created skills that peacetime didn't value. Decisiveness under pressure. Improvisation with limited resources. Willingness to break rules when rules didn't work. But Patterson's experience was different. His antenna innovation had demonstrated engineering aptitude. The Army needed engineers. Post-war military was modernizing. New equipment, new doctrine, new technology. Officers who understood both combat operations and technical innovation were valuable. Patterson was sent to MIT in September 1945. Army-funded graduate program in electrical engineering. 2 years of intensive coursework. Radio wave propagation. Antenna theory. Communication systems. The formal education and concepts he'd learned practically in combat. He graduated in 1947 with a master's degree. His thesis: optimizing radio communication in armored vehicles under field conditions. The thesis formalized what he discovered empirically in the Ardennes forest. Analyzed antenna configurations, calculated radiation patterns, developed design principles for military radio antennas. The thesis became required reading at the Signal Corps Training School. Its principles influenced antenna design for the next 2 decades. The Korean War communication equipment, Vietnam-era radio systems, all incorporated lessons from Patterson's research. In 1948, Patterson was assigned to the Signal Corps Research and Development Laboratory, the same facility that had analyzed his antenna modification 3 years earlier. His job was developing next-generation tank communication systems. He worked with civilian engineers, former Signal Corps officers, radio manufacturers, the team that would design communication equipment for the Cold War military. The work was different from combat. Slower, more bureaucratic. Decisions required committee approval. Innovation required documentation and testing and validation. But Patterson understood why. Peacetime military couldn't operate like wartime military. The urgency was different. The consequences of failure were different. Still, he pushed for field testing, for getting equipment to actual tank crews before finalizing designs, for listening to feedback from soldiers who'd used the equipment. The lessons from December 1944 stayed with him. Good ideas came from people facing real problems, not just from engineers and laboratories. One project illustrated this principle. In 1951, the Army was developing a new tank radio for the M47 Patton tank. The prototype used a vertical antenna. Patterson objected, argued for horizontal dipole configuration based on his Ardennes experience. The engineering team disagreed. Their calculations showed vertical antennas were more efficient. Patterson insisted on field trials. Sent prototypes to tank units in Germany. Vertical antenna version and horizontal dipole version. Let the crews test both. Report which worked better. The field reports were unanimous. Horizontal dipole provided better range, better signal quality, easier maintenance. The crews preferred it overwhelmingly. The engineering team accepted the field data. The final M47 radio system used horizontal antenna configuration. That pattern repeated across Patterson's career. Design differences, engineering disagreements, field testing providing decisive evidence. His experience in 1944, building what worked instead of following what was prescribed, became his methodology for equipment development. He retired as colonel in 1968 after 27 years of service. His final assignment was Director of Combat Communications Development at the Signal Corps. His office walls displayed photographs, tank formations in Germany, radio equipment prototypes, engineering diagrams, and one photograph from December 1944. Patterson's Sherman tank with its horizontal antenna wires extending from the turret. The stupid-looking modification that changed how armies communicated. Post-retirement, Patterson consulted for defense contractors, advised on military radio development, taught occasionally at army schools, published papers on communications theory. But mostly he lived quietly. The recognition he'd received, the promotion, the awards, the professional success, mattered less than knowing the innovation had worked. The modified antenna had saved lives. Improved coordination had prevented tank losses. Better communication had helped win engagements. That was what mattered. Not the engineering analysis. Not the official approval. The practical result. Soldiers surviving who might not have survived otherwise. Chapter 10. Legacy in Modern Warfare. Modern armored vehicles communicate nothing like the 1944 Sherman tank. Digital radios, satellite links, encrypted networks, data transmission, GPS coordination. The technology is unrecognizable compared to World War II equipment. But the principle remains identical. Coordination wins battles. Individual tanks, operating independently, are less effective than coordinated units. Communication enables coordination. Better communication enables better coordination. The fundamental tactical equation hasn't changed despite technological advancement. The M1 Abrams tank uses multiple antenna systems. UHF, VHF, satellite, data link. Each optimized for different communication requirements. Each designed with lessons from field experience. Each incorporating principles Patterson demonstrated in 1944. Horizontal radiation patterns for ground-level communication. Impedance matching for efficiency. Robust construction for field durability. But modern tanks face new communication challenges. Electronic warfare. Jamming. Interception. Cyber attacks. The radio environment is contested. Enemies actively work to disrupt communication. The solution isn't just better antennas. It's resilient networks. Multiple pathways. Frequency hopping. Spread spectrum. Technology far beyond anything possible in World War II. Yet the core insight remains. Tank units need reliable communication to coordinate effectively. When communication fails, coordination fails. When coordination fails, tactical advantages disappear. 100 modern tanks without communication are just 100 individual vehicles. 100 modern tanks with reliable communication are a coordinated force. This principle extends beyond armored warfare. Infantry units, aviation, naval operations, joint operations across services. All require communication. All rely on coordination. Modern military doctrine assumes reliable communications at all levels. Battle networks connecting soldiers to vehicles to aircraft to headquarters. The entire system dependent on communication links functioning properly. Patterson's contribution wasn't inventing radio communication. It was demonstrating that field innovation could solve communication problems faster than official procurement. That soldiers facing real problems could develop real solutions. That equipment designed in laboratories sometimes needed modification to work in actual combat conditions. That lesson influenced how modern militaries approach equipment development. Rapid prototyping, field trials, user feedback, iterative design. The procurement cycle shortened from years to months, sometimes weeks for critical equipment. The goal? Get working solutions to soldiers quickly instead of perfect solutions slowly. The F-35 fighter aircraft development program faced criticism for taking too long. 20 years from concept to deployment. $1.7 trillion total program cost. But the aircraft incorporated feedback from pilots throughout development. Test pilots suggested modifications. Combat pilots reported problems. Engineers adjusted designs. The final aircraft reflected real, operational requirements, not just theoretical specifications. That's Patterson's legacy. Not just the antenna design, the methodology. Test with actual users. Get feedback from people who'll use the equipment. Modify based on field experience. Repeat until it works in real conditions. Don't wait for perfect. Deploy working solutions and improve iteratively. The Patterson antenna itself is obsolete. Modern tanks don't use anything resembling its horizontal dipole configuration. The technology advanced. The frequencies changed. The requirements evolved. But the impact persists in military culture. Field innovation is valued. User feedback is incorporated. Equipment development includes extensive field testing. When Patterson died in 1992, at age 71, his obituary in Army Times mentioned his World War II service, mentioned his post-war engineering career, mentioned his contributions to military communications. It included one quote from an interview he'd given in 1985. The best solutions come from people facing real problems. Engineers and laboratories can design elegant systems, but soldiers in combat know what actually works. Listen to the soldiers. They'll tell you what needs to change. That quote became popular in military education, taught at West Point, at command and staff colleges, at leadership courses. The idea that innovation comes from practitioners, not just theorists. That field experience matters as much as formal education. That sometimes breaking rules produces better results than following them. December 1944. Ardennes Forest. One tank commander building an antenna from spare parts because the standard equipment was inadequate. That improvisation saved lives. Improved tactics. Changed how armies communicated. Not through official channels or engineering approval. Through field innovation and practical testing and soldiers sharing what worked. The horizontal wires looked stupid. Officers called them ridiculous. Regulations prohibited the modification. None of that mattered when 40 tanks could coordinate like one machine. When communication enabled tactics that won battles. When field innovation proved better than official equipment. That's the lesson. Not about antennas specifically. About innovation generally. About listening to people who face problems directly. About testing solutions in real conditions instead of controlled environments. About sometimes the best answer comes from a field, not the laboratory. The stupid antenna trick that saved 40 tanks. The field modification that changed doctrine. The unauthorized innovation that became standard equipment. Patterson's legacy, proving that soldiers with real problems often develop better solutions than engineers with theoretical models. Stories like this deserve to reach those who value them. If this account held meaning for you, consider helping others discover it. A like tells the algorithm to share this with similar audiences. Subscribing to the channel and enabling notifications ensures these stories reach you when new accounts are published. Your engagement becomes a form of historical preservation, connecting those who seek this knowledge with those who've taken time to document it properly.